This is NetBSD 10. This is a modern and well-maintained operating system that just had its most recent release in 2024. We are watching it boot up on a 25 MHz DEC VAX 3100M40 that was officially released in 1993, but has the performance and specifications of a 1980s VAXen. I'd call it a modern version of Unix, but as it was not created in the Murray Hill region of New Jersey, I can only call it a sparkling Unix-like. This machine takes anywhere from 10 to 15 minutes to boot up on a good day, and your host and commander has been spending the last month getting it running with nothing more than a mop, bucket, and some soap. Complicating this project was that this microvax isn't in my physical possession. I'm accessing it remotely from hundreds of miles away. It's hosted by Black Coffee Drinker, one of my Discord mods, who specifically bought it for the purpose of watching me suffer. My mission, which I had inadvertently accepted, was to get this microvax booting off the network, dump its hard drives, and then see if we could get NetBSD 10 fully functional. In his own explorations of the machine, Black Coffee Drinker had experimented with trying to get the machine to net boot off a Linux host server. This involved using an unofficial fork of NetBSD's MOPD daemon that has additional code that allowed it to work on Linux. With it, he managed to get NetBSD 1.5.1 to start once, but was unable to reproduce the result. Not long after this, Black Coffee Drinker managed to reconfigure his network to allow me access, and I picked up the work from there. Fortunately, I'm not alone in this quest. NetBSD, unlike many other things I've made videos on, has both documentation and source code. More importantly, NetBSD has long maintained a very useful document talking about diskless booting on pretty much every machine in existence. If you want to know how to run NetBSD on a PowerMac G5 with a PA RISC host machine running HP Unix 8, then this doc has you covered. It's here where we get our first introduction to MOP, or DEC's Maintenance and Operation Protocol, and oh boy, it's a beast. This protocol predates TCP/IP and ARPANET. It's a layer 2 protocol that can best be described as magic. DEC's MOP protocol is more akin to a remote debugger than, say, a modern boot protocol like Pixie or even Ripple. When any VAXen tries to boot off the network, it starts looking for a MOP server. That MOP server has the responsibility of writing the first stage bootloader into the VAX's memory and then jumping to it. This also involves calculating the load addresses and more, and the NetBSD MOPD has special code that runs on certain VAX models, but not others. I spent some time fiddling with it, but there were simply too many possibilities. I knew it was at least not entirely broken, since Black Coffee Drinker had managed to get NetBSD 1.5 to boot once, but that means it was either depending on uninitialized memory or application side effects to work. If this sounds like undebuggable spaghetti, you are absolutely correct. So, it was time to start removing variables. What if I tried to boot something else? At this point, I was only trying to dump the disk. We knew from the physical examination of the system that this microvax had a SCSI hard drive, but there had been no signs of life when we tried to start from it. I didn't necessarily need to be running NetBSD to do that though. Furthermore, there was an obvious thing to try next. On GitHub, the most recent port of MOPD to Linux is the DreamLayers port. This port was done about 4 years ago and also adds support for booting Ultrix. Ultrix was DEC's port of Unix, and as far as commercial Unixes go, it's strange. Strange enough that I could do an entire video on it, but for now, let's stay focused. To even test if Ultrix was a viable option, we were going to need a few files from the installed system, specifically a copy of the netload binary, a configuration stub, and Ultrix's kernel in the form of VM Unix. More to the point, I needed to install Ultrix, copy the files out, and hope NetBSD MOPD on Linux would work. Fortunately, since VAX has now been around for over 5 decades, it's extremely well emulated by OpenSimH. As such, I could simply install Ultrix with relatively little fanfare by using the very helpful information on the Computer History Wiki, and then simply FTPing the files I need out. So I did. Afterward, I went through, copied out the necessary files, and I was ready for the next step. Having climbed this cliff of netbooting pain, it was certainly all worth it. Right? Well, kinda. What I didn't know at the time is that DEC never supported Ultrix on this machine, and its VM Unix kernel doesn't support the KA45 processor at the heart of this microvax. This manifested as the microvax downloading the Ultrix loader and the configuration step, and then falling over not too long after. However, this trip through ancient Unix did lead to the first real breakthrough on this project. Past me at this point was beginning to suspect there was a problem with MOP-D, and thus was hoping that something more official might stand a better chance at working. The thought was if an unofficial MOP-D written for NetBSD and then hacked to run on Linux could start Ultrix, then presumably Ultrix could start Ultrix over the network. That way, everything in the stack would be DEC tested, DEC approved. Actually doing this, though, is quite painful. Setting up Ultrix with its diskless management services requires knowing more about BSD disk label partitioning than the doctor recommended dose. It also doesn't help that I don't think DEC believed in debug messages, since its golden child, VMS, was so perfect as to never require them. This of course made my life all the more fun as I increasingly began to resort to what I like to call YOLO debugging. However, sometimes you get lucky. I ended up putting NetBSD 10's mop loader on Ultrix's mop mom after running it through the mop copy command and then typing boot ESA0 on the VAX. This, against all odds, worked. Or well, I got the NetBSD VAX first stage bootloader to load. Seeing the first signs of NetBSD running definitely sparked joy in this one. However, I still need to get NetBSD to actually boot. However, it was quickly becoming clear that this wasn't going to be the end of it. On my first attempt to start NetBSD 10, the system died with a glitch-out terminal. The next few boot attempts went roughly the same way. Of course it wasn't that easy, although to be fair, this outcome wasn't entirely unexpected. NetBSD's VAX port was created in the mid-90s, and the OS as a whole has advanced and changed in that time. VAX support, along with many other legacy platforms in NetBSD, are known as Tier 2, meaning that support and QA are done on a best effort basis only. A regression affecting an uncommon model of VAXen could easily go unnoticed for years or even decades. Still, at this point, I was optimistic that we could get this working. Working backwards, I eventually determined that NetBSD 7.2 would at least show signs of life. Finally, actual progress. After getting the NFS root sorted, I was greeted with this login prompt after a 15-minute startup sequence. Now I could log in as root. Eventually. Any day now. And we're good. The first order of business was to read out the hard drive. At this point, I started live streaming my efforts on the VAX, starting with 2 public but now unlisted live streams covering the 16 hours it took for NetBSD 7 to very slowly read out the internal 4 gig hard drive. Patience is a virtue on these kinds of projects. This is also a good time to remind folks to like and subscribe if they like watching digital paint drying. Your contributions go a long way, especially when it turns out you spent 16 hours dumping a scratch drive. Oof. If you can feel my pain here, this is a good time to consider becoming a Patreon or otherwise supporting the channel with the links in the description. Self-promotion aside, as far as I can tell, this microvax has never had an operating system installed in the first place. It was likely this machine was part of a larger VMS cluster, although I have no idea what kind of workflow it might have been running. That said, I've been told that these entry-level microvaxes were often sold by DEC to provide terminal or application services in a given location for a small number of users. However, is this our mission accomplished moment? I did technically get NetBSD running after all, but let's be real here, I wasn't going to be satisfied with just running an older version. I wanted to be running the latest and greatest on hardware too anemic to appreciate it. Based on everything I had experienced to this point, I had been operating under the assumption that NetBSD's MOP code was just kinda buggy. By this point, I had also received reports that NetBSD 10's install CD was known to work without issue on very similar hardware. Assuming the problem was due to MOP, then it was possible if I could simply install NetBSD 10, then it all might just work. If nothing else, testing NetBSD loading off the hard drive would eliminate more variables and help me understand just what's going on here. There are a couple ways to install NetBSD from a netboot environment. The easiest and most straightforward way is to simply boot the install.ram file, which is a special stripped-down version of the NetBSD kernel with an integrated RAM disk with the installer. Since I expected the NetBSD installation to take hours, this seemed like a perfect opportunity to get back into live streaming. My plan is that if I could install NetBSD 7 successfully, then I'd upgrade toward NetBSD 10. However, since we were live, I loaded the NetBSD 10 install kernel first just to show what happens. However, much to my surprise, NetBSD 10 began to start up. This was then followed by the main screen of installation. However, this wasn't a cause for celebration, and I get suspicious when something starts working without a known reason. At least on the surface though, it seemed like everything was working. Over the next 4.5 hours, the stream and I watched NetBSD 10 slowly download and install itself. However, on the reboot, the system fell over just like it did before, with junk data being printed to the console. That meant all of NetBSD 10 was working to install, just not, run as an actual operating system. This, however, gave my first solid clue towards debugging. I had a known working config and I had a known broken config. It was just a matter of isolating the changes. By taking a look in the NetBSD source tree, we can see that these two configurations actually have quite a few differences between them. As compared to the generic kernel, the install configuration disables unneeded devices and also integrates a small RAM disk, which includes the installer and all necessary utilities. Nothing jumped out when examining the two different configurations side by side. However, by bisecting the differences in the config, I eventually isolated the problem to the LCG device driver. This driver is present in the generic kernel used to start the system, but isn't present in the install kernel. However, why was this driver causing the VAX to hang? And perhaps more importantly, what is LCG in the first place? To answer the latter question, LCG refers to a frame buffer or video output device that was used in a few of DEC's VAX station machines, including the VAX station 4000 VLC, a machine DEC released in 1985 and was also known as the Tiny VAX. Why is a frame buffer driver for a 1980s VAX trying to load on a machine first released in 1993? As it turns out, I've already given you the answer to this question. More specifically, when I said this, we are watching it boot up on a 25 MHz DEC VAX 3100 M40 that was officially released in 1993, but has the performance and specifications of a 1980s VAXen. As I dug into the code, it turns out DEC was quite literally selling this system with 1980 VAX hardware in a 1990s case with additional cost reduction. However, to explain why this is breaking NetBSD, we need to talk about how device drivers work on a high level. Inside every driver in NetBSD, you will find two functions known as match and attach. As the name implies, NetBSD's standard kernel is generic, meaning that it will run on pretty much any model of machine within the same architecture family. That also means it has a large number of device drivers for all the hardware that may or may not be present in a given machine. The match function determines if the hardware is present, and the attach function initializes it and makes it available for NetBSD to use. Frame buffer devices like LCG also have additional probe and attach functions, which allow them to initialize early in the boot sequence so kernel start messages can be printed to a display. This is the LCG CN probe function. Looking at LCG match and LCG CN probe, we can see that both drivers check the board type and see if we're on a VAX board type of 46 or 48 and then attach. The 48 board type corresponds to the VAX station 4000 VLC, originally released in 1985, which would have the LCG frame buffer device. The VAX 4000 VLC also shipped with a KA48 processor. Our first hint to solving this mystery is actually in NetBSD's boot messages. If we look closely, NetBSD thinks we're running on a KA48 processor as well, although the built-in firmware correctly reports that we're running on a KA45 processor instead. Digging into the code a bit further, we can determine that NetBSD checks two bit fields for the CPU and board values. On our microVAX, these CPU and board types return VAX type SOC and board type 48, which is identical to what a VAX station 4000 VLC would have had. This is why the LCG driver tries to attach on a machine that has no frame buffer. The MicroVAX itself is reporting that as a cost-reduced version of a 1980s VAX that did have a frame buffer, and as a result, the LCG driver tries to initialize a non-existent frame buffer device, leading to a killer poke in kernel mode, which locks up the system. At least it didn't release the magic smoke. Actually figuring this all out took a fair bit of time and multiple debugging streams. One thing that helped was loading up OpenBSD, which used to have a VAX port up until version 5.8. It also has a copy of the LCG driver like NetBSD does. However, OpenBSD has more sophisticated platform code and properly detects that this is a MicroVAX and shouldn't have LCG loaded. I've sent a long email discussing my findings to port VAX along with a potential patch, so with luck, later versions of NetBSD VAX will just work on this hardware going forward. If not, this YouTube video and my streams should have you covered if you want to run NetBSD on this specific type of VAX and you are patient enough to sit through the experience. So, mission accomplished for real now? Well, yes, NetBSD 10 is now working. I even found some pre-compiled software. Distributed.net, one of the original internet grid computing projects, has a NetBSD VAX client that still works. However, more to the point, this is a VAX system that I have full remote control of, and honestly, I've been feeling inspired. Throughout this project, I got a pretty good look at the low-level bits of the NetBSD VAX port, and well, I had a few follow-up ideas on where I want to go next. I had this rather silly idea of seeing if I could possibly revive the OpenBSD VAX port, or possibly seeing if I could modify older VAX-based versions of older operating systems to run on this hardware. I already have some ideas on how I might be able to get Ultrix to run. Mach 86 also looks straightforward to tweak. There's then of course VMS, which should just work, but that has its own separate can of worms. That said, I've walked away quite impressed with NetBSD thus far, to the point that I will likely be using it on future projects going forth. In fact, I have enjoyed this experience so much that I may also be doing some work on the NetBSD VAX port down the line, such as helping to resolve ATF test failures and helping to sort out package source issues. As compared to Linux, I greatly appreciate a largely stable base that doesn't seem to drastically reinvent itself every 5 to 10 years. However, such projects are dependent on your support, so if you've enjoyed this content, consider liking or subscribing. If you really enjoyed this content, consider supporting the channel on a recurring basis on Patreon or a one-time basis on Ko-fi. If you're also interested in supporting NetBSD development as a whole, they are a registered 501c3 charity in the United States, and I will leave a donation link to their donate page in the description. As usual, this is your host N Commander signing off and wishing you all a pleasant day.